With great pride, we invite the working mind and the chairperson of the CEA 2022, Mr. Mercedes, to deliver the welcome address.
A very good afternoon to the dignitaries on the virtual dais, chief guest of the day, respected professors, and all the students. It gives me an immense pleasure to welcome you all to the inauguration of Civil Engineering Association. CEA was founded in the year 1964 with an aim to enlighten the students with the current trends in civil engineering. I am really proud to say that we have upheld the tradition of 58 years, have kept rising the bar every year, and been testing ourselves in this journey. We have a Herculean task ahead of us, and we have just the right people to efficiently and execute the same. The inauguration of Civil Engineering Association, which marks the start of all the official activities for the academic year 2021 to 22. As the agenda of CEA for this year, we are planning to organize a series of guest lectures, seminars, and exclusive workshops with the betterment of the students in mind. Mainly focus will be on the topics to provide a great career building elements. Also, we will have an interactive session with our faculty at least once in a month to explore various opportunities through their experience and knowledge. Giving the maximum exposure in this visual atmosphere is our ultimate aim for this edition. Alone, we can do so little. Together, we can do so much. With this fresh, talented, and energetic team, I can say with certainty and all the endeavors are going to be a huge success, and we will set a new benchmark in this year 22. Also, I would like to take this opportunity to welcome our esteemed chief guest of the day, Ms. Minimal Corolla, Vice President McAfee Environmental Solution, respected HOD Dr. G. Swaminathan, Professor HAG Dr. Moses Sandakumar, our faculty advisor Dr. Jeevan Joseph, and all the faculties joining with us today. It gives me a great pride to share this platform with you in this wonderful occasion. Also, I wish the core team of CEA all the success for the days to come. Thank you.
Thank you, Mercedes. Next up, we'd like to welcome our beloved head of the department, Dr. G. Swaminathan, a source of constant support throughout our endeavors, to give an overview of the department.
Good afternoon to one and all who are joined in the virtual platform. Respected chief guest of today's function, Mrs. Minimal, Dr. Moses, the president of today's function, Dr. Jeevan Joseph, the staff advisor of CEA, Mr. Mercedes, and Mr. Prasanna, my colleagues, professors, and student friends. It gives me immense pleasure to be sharing with you the idea of putting forth or marketing our Department of Civil Engineering. As all of you know that Tiruchirappalli is the geometrical center of the state of Tamil Nadu, and it is well connected with by road, rail, and air. It's a commercial center as well as a temple city. So the temple for education is none other than the Regional Engineering College, which was founded in 1964 by the visionary Professor Manisundaram, who was the first principal of REC Tiruchirappalli, and we took pride in one issue that he was a civil engineer by profession. So he was the one who was cited this institute, and this Department of Civil Engineering was started in 1964. Very few departments were started in 1964 when this institute by name REC has come into existence. From then on, REC was the most sought after name. So we have been maintaining the reputation over these 58 years that we are the top among the all RECs, and nowadays we call it as NIT. So the NIT Tiruchirappalli, we are the top among the NITs in NIRF ranking, and we stand at 23rd in overall. So every year it's a question of improvement. So we have started from 11th and we have moved over to the 9th position. So we are proud to say that we are one in the top 10 engineering colleges in India. So our alumnus who have graduated from this institute are spread over all over the world, and they are holding the top position. And to say about the department, which was started in 1964, is the oldest department in this institute. So we have got a BTech program, and our intake is not less than 120 students per batch rather. So we have got 500 and odd BTech students. We are running MTech courses in transportation planning and management, structural engineering, environmental engineering, which was started under the aegis of TechCube, construction technology and management. This is the course, one of the few courses which have been sponsored by the industrial giant Larsen and Toubro, because IITs were running this course, and Larsen and Toubro volunteered that NIT Tiruchirappalli and NIT Surathkal should they offered permission for us, and we are very happy that we are one among the four which is hosting this program of unique nature, MTech in construction technology and management. And very recently we have started geotechnical engineering. So we have got a state-of-art laboratories. We have got we are proud to say that we are recognized as a center of excellence in transportation engineering, and we have got what is called a CTRANS. And of all the departments, we are the leading money earners for the institute rather. So we can proud to say that our annual earnings has touched not more than 3 crores rather per year. So we are going ahead, and also we are helping the general public administration in all their issues. So this is about a department, and we also run a PhD program, and we have got expertise in all areas, like including water resources. And I'm very happy to be part of this. The CEA activity, even though it has started in 1964, as rightly put up by our Mercedes, the student activity picked up only during 1988, because we thought that why not we have a student seminar inviting student friends from other institutes. The first of its kind, it was called as Enviro 92. Most of our students would not have been born at that time. So Enviro 92. Later on, it was christened as Moments, and every year we have a Moments. See, even during the COVID time, we have not forget that, and we managed it, and not only managed it, we managed it very well. So this is our department. So even though we will go endlessly, I curtail myself, giving way for other speakers. Thank you for the opportunity. I wish the Civil Engineering Association all the very best, and as rightly pointed out, it should blur with activity, because our young minds, I know the capability and capacity of our students, they will do wonders. I am expecting that they are going to perform in a right spirit, in a more jubilant way. Thank you for the opportunity. Thank you.
Thank you, sir. Next, we request the driving force behind the CEA, a guiding light to all the students, our inspiring staff advisor, Dr. Jeevan Joseph, to present a glimpse of the CEA over the years.
A very good afternoon. Respected Chief Guest for the day, Engineer Minimal Kurula, Vice President McAfee India, Professor Moses Santakumar, presiding the function, Head of the Civil Engineering Department, Professor G. Swaminathan, Office Bearers of Civil Engineering Association for 2021-22, dear colleagues, supporting staff members, and my dear students. So we initiated our discussions on the theme for the Civil Engineering Association 22 way back in September. So after several discussions and meetings, unanimously we agreed upon a theme that is relevant and fitting to the current day scenario. Of course, the head of the department shall be revealing it in a couple of minutes' time. As we all are aware of, the pandemic had made a severe impact on the civil engineering industry for the past couple of years. Many new projects got shelved, ongoing projects faced funding issues, delayed project completion due to resource crunch, and so on. So we all pray that the situation will improve soon and the industry will again continue in its full swing early this year. To speak about the Civil Engineering Association, the association had its birth with the motive of bridging the academic life of the students with the professional world, as mentioned by Professor Head of the Department. The platform provides them the experience of managerial skills, teamwork, and a flavor of organizational behavior, including the financial management. To a large extent, we are successful in linking the alumni and the industry with the department. And we also could arrange industrial lectures from a field expert in the construction industry. We were successful in conducting the department cultural event moments last year with more than 300 participants for various events and workshops. The event being set completely in online mode, we could make participate people from Srinagar to Kerala. Happy to share that we had active and quality outcome from this knowledge sharing platform. So this year we are planning the events even at a larger platform, and we expect international entrant for the various events that are being planned. We have a very dedicated team to fulfill all the activities planned under the aegis of CEA. Though we miss many experiences of being physically present inside the campus, the online life has taught us that we can have more information sources from the world, informations that are made available free of cost. I take this opportunity to suggest all the students of the Department of Civil Engineering to take part in online lecture series, events, workshops, etc., which would elevate them to a step ahead and make you competent enough for facing the challenges ahead. I wish all the very best for the team. Thank you.
Thank you, sir. As we culminate the long wait, we reveal to you the theme of Moments 2022. We request our beloved head of the department, Dr. G. Swaminathan, to do the honors.
Thank you all, and I'm very happy to share with you the theme of Moments 22. It is a Latin word. It is meant for process and art of construction, edificium. So that is the theme, rebuilding the realm. So I'm very happy to share with you the theme and the tagline. Thank you.
Thank you, sir.
Thank you. Thank you, sir.
Thank you, sir.
Today we have with us the person who always strives towards the progress of the department and supports us in every aspect. It is a pleasure to welcome our cherished HAG professor, Dr. Moses Santakumar, to deliver the presidential address.
Respected Chief Guest of the inaugural function of Civil Engineering Association, Mrs. Minimal Kurula, the Vice President of McAfee, beloved Head of the Department, Dr. G. Swaminathan, the Faculty Advisor of CEA, Dr. Jeevan Joseph, the Chairperson of CEA, Mercedes Robert, and the General Secretary, Prasanna, and other office bearers of CEA, my dear colleagues, faculty, staff, and dear student friends. A very good afternoon to all of you. It is indeed a great privilege for me to preside over this inaugural function of the Civil Engineering Association. Of course, we are living in difficult times, the pandemic, and we are having online classes. We are yet to resume normal activities in the institution and the department. So under these trying circumstances, I'm really happy, and I would like to commend the efforts put in by the staff advisor, Dr. Jeevan Joseph, as well as the team, and then the other students to organize this inaugural function, as well as follow up and have various activities of the Civil Engineering Association. Of course, we have been having online classes. All the faculty know how difficult it is to relate to the students, to interact with the students, and students are also feeling a bit out of sorts, I'm sure. And we are fearful that we may not meet our students before they pass out. So under all these circumstances, still we are trying to do a good job, and I'm sure the students are also cooperating in the teaching learning process. But I mean, there's nothing like physical interaction and then students clarifying doubts or interacting with the faculty, visiting the faculty in the department. None of that is taking place. So it is really important that under these circumstances to have other channels of interaction, other channels of knowledge acquisition, knowledge sharing, and so on. So Civil Engineering Association will play a very crucial role in this regard, wherein the students are exposed to experts from various fields, and then they are in a position to augment their knowledge, whatever they are gaining through the regular classes and coursework, and also building up their managerial capabilities and their entrepreneurial abilities, and generally, I mean, adding value to their degree, what they are earning, and involving in extracurricular and co-curricular activities. So all these are very important, especially during these pandemic times. Of course, there are also some positives of the pandemic. I'm sure you would have heard, I mean, you would have known that the death rate on our roads have gone down. The tragedy of tsunami on our roads, which takes away 1.5 lakh lives every year, has diminished somewhat. So even though we have lost nearly 5 lakh lives to the pandemic, we are at least happy that the traffic is diminished. And that has also got the positive aspect of reducing our air pollution and the other deleterious effects of the growth. You might have seen some shares, on the social media about how we are able to see Eiffel Tower, for example, because the air is so clear. So these things are positive, and also many of the companies have started making money by cutting down on the cost of providing tea and snacks to their employees. They are making them work from home. So that is having the positive aspect of reducing the traffic also on the streets. So these are also positive aspects. But coming to our institution and the teaching learning process, I think the most important positive aspect is the ability to go on the digital platform to have webinars and so many other knowledge sharing activities. For example, I mean, I've been giving many lectures now in faraway places which I would not have been able to give during normal times because of travel problems and so on. Maybe we might not have had Madam Minimal Kurula herself giving this lecture here, the expert lecture on sharing your knowledge. I think she has a flight to catch in the evening. So all that is possible because we are on the digital platform. So many webinars are being organized, and then we are also learning new things. We are able to listen to experts from faraway fields, including people from abroad. I mean, whole conferences have been conducted online, like the CTSM, where so many people have joined online from the US and delivered. So it is for us to leverage this platform, and for the Civil Engineering Association to build on this and have many more digital activities, webinars, and so on. I just want to convey three things. That is, one thing is this, that is, they must organize as many online events, including interactive events like quizzes and then workshops and so on. That is one thing. Secondly, it is usually found that the team spends their entire energies on moments. So that is the only, that is the USP of the CEA as well as the civil engineering department. But you must also work on the other events and so that the people are benefited, students are benefited. I'm really amazed to see that there are 264 people online. This has never happened in a CEA inaugural ceremony, isn't it? It will be less than 100, and it's impossible to mobilize during normal time. There is another advantage of the digital era we are living in. So students should concentrate on that. Thirdly, I would advise the students to involve the postgraduate students also. Usually the civil association is a clique of people who are close, and then they may not involve the postgraduates. But as Dr. Swaminathan explained, we have 5 postgraduate programs and a lot of research scholars who would also, in fact, I usually ask my, the project group to interact with the MTech students as well as the PhD scholars, further their knowledge. So please involve the PGs also in the CE activities. So with these few words, I wish the CEA all success. And I just, before I conclude, I would like to give a brief introduction about the chief guest of today. I am really happy, madam, that you have set aside time from your busy schedule to inaugurate this Civil Engineering Association and also deliver an expert lecture, which will be valuable and inspirational to our students. I just want to say a few words about her. Mrs. Minimal Kurula is the Vice President of Makafari. She is associated with the well-known Pambier River Basin project in connection with the Kaveri Water Tribunal. She worked on this project during her tenure in the Irrigation Department of the Government of Kerala. She is very active in codal formulation committees of ISO, BAS and IRC, and has authored a few important guidelines as part of the authoring group. In addition, she is also a guest faculty of the Indian Academy of Highway Engineers. She got unique opportunities to get involved in challenging projects of the nation in the domains of slope stabilization, riverbank stabilization, ground improvement, and disaster mitigation projects, etc. If I may add, Ms. Minimal is a national resource person who is instrumental in developing a few new products and engineering systems in the field, assessing the techno-commercial benefits of such innovative systems in the real application area. We are more than honored to have your presence, madam, virtually to celebrate the occasion. Of course, I may also mention that we have a connect by way of the Geotextiles. Makapari is very famous for the synthetic geotextiles, which are used on many of our expressways. And we have a coir project. In fact, we have 3 or 4 coir projects coir board projects where we are promoting the use of coir geotextiles. So this may seem some kind of a rivalry, but I would say that they complement each other. Coir geotextiles are used in the rural roads where we are providing, we don't need much strength, but we need material which is compatible with the natural environment, whereas Makapari is working on probably synthetic geotextiles which are very much needed for higher strengths with high MSAs exceeding 100 and 150 MSA traffic on expressways. So I'm sure we will have more opportunities to interact, madam. And once again, I thank you on behalf of the department for accepting our invitation to be the chief guest. And I am sure you will inspire the students during your presentation. Thank you one and all.
Thank you, sir. We at CEA have prepared a short video for the audience to reveal the theme of the upcoming rendition, Moments 2022.
Hello.
Yeah, Abhishek, please continue. I think there is some, connectivity issues. Yeah.
Now we extend our warmest greetings to the woman of the day, Dr. Minimal Kurulla, the Vice President of McAfee Environmental Solutions Private Limited. She is a model professional in the field of water resources engineering and has showcased utmost excellence with multiple years of experience under her crown.
She is known in the industry as an expert for providing solutions from simple to complex, weak soil slide to rock slope instability and erosion problems. As the Vice President of the McAfee Environmental Solutions Private Limited, Dr. Minimal Kurulla has made magnificent, unique contributions with products and systems that have the least impact on the environment. She also has numerous publications under her name. We now take this opportunity to humbly request Dr. Minimal Kurulla to address the crowd with her inspiring words.
So, thanks to all. This is a great honor, and let me express my sincere thanks to the organizers and the distinguished the speakers, Sandal Kumar sir and Saminathan sir, Dr. Jeevan Joseph, and all of you to spend time with me for a few minutes, or the association, any type of engineering association for me, that's so important, because what I learned from my past 30 years after the graduation, the hard work, the knowledge, the performance. So this is what we all are thriving for as the educated community. But our success will not only depend on the relations what we make, the associations what we make, the collaborations what we make. We will get, apart from that success, we will get big way of fulfillment also. So through this type of platforms, what the students are getting, as per me, in the simple words, the friendship, which is always a happiness. So apart from all the stress, all the pressure of achieving the great heights of the knowledge level, the friendship gives a very special meaning, because here the friendship is the like-minded people, the people who are working in the same domain, someone we can easily connect at any part of our life, later life. The second is, of course, the networking. I don't know, the networking is having a big meaning for you. I got the real meaning of networking once I started getting the more managerial responsibilities in McAfee, as well as I started working in the caudal committees of Bureau of Indian Standards, ISO, and IRC. Everywhere I found that it's not just what I tell or what I know. The way I am able to influence others, the way I am able to communicate to others, the way I am able to understand what is the problems what really everyone faces. Not only me or my organization, but others, even my competition. Then only I will be able to do anything substantially with everyone's concurrence. And that's very important. When you go up, or when you are able to do something for the society, and at the same time, you are able to sustain your own career, your own profession, for that lot of relations are required. And finally, we talk about knowledge, we talk about relation, but finally, a very important part is there, whether you are in a government job, whether you are in a corporate job, whether you are in an academic job, a team. A team means something beyond it, because it is not just networking, not just relation making. It is the ability to work as a team for a common purpose. 1 + 1 is 11 when it is a team, not just 2. Because when you work as a team, it is big trust will be added for each other. Big purpose will be added. So all these will come. How this can come? It cannot be. We cannot all on a sudden start from tomorrow onwards, I will be a good team player. We may not be able to do that. By being a part of a team, wherever we get opportunity, that is how we will cultivate that habit. And for me, this is another place I'm seeing the professors, the teachers, everyone together, making a platform for the students to come together and understand how we can do the great networking, great friendship, and cultivate the ability to work as a team. And I have a lot of memories about NITT Trichy, which I want to share, but I have the responsibility to give an expert lecture also. But something which is immediately coming to me at present is about the 6 interns who worked with me from NITT Trichy this year. That is the latest my experience. Of course, IGC Trichy, there were a lot of interactions, but the good experience, the 6 students whom I picked up from the PG, the geotechnical branch, after they worked with my team, almost 2 weeks just passed. And I just asked them, oh, you look very much seasoned, and I would like to compliment your institute. And to my surprise, they told that they are the first batch of the geotechnical stream. I was not able to believe that. The way they were acting as the interns, it was like they were true professionals. And I really feel that there is a influence of the institute, because all were like that. Again, when I expressed, they were so humble. They told that, in fact, we are not in the campus. We are just seeing each other in online meetings. We are not seeing our professors. But to be honest, I'm totally got inspired by them, which I communicated to the professor. And I want to compliment. This is the true reflections of the culture of an institute. It will be seen how the students will be performing, whether they are as interns, whether they are as the future leaders, whether they are as the finest engineers, they will show it. So I'm sure this association initiation now for this year's activities, that definitely again amplify the reflections which the students and the teachers of this institute, which were already showing in the industry. So now let me move to my my next responsibility. Here for the expert lecture, what I have selected in the field which I am working. Being a civil engineer, definitely I have to work with a lot of construction materials. But what I have chosen is, as Sandal Kumar sir has said, it's the more about the innovative materials like geosynthetics. But it is not just about geosynthetics, it is about bioengineering materials like coir and jute. We use a lot coir and jute, and especially I used to advocate a lot wherever it is required. And apart from polymeric and this bioengineering products, I work in a spectrum of materials which are good for rockfall protection, landslide mitigation, where just geosynthetics or coir alone will not work. We may require steel products, different types of drapery systems, steel meshes, energy absorption panels and all. So it's not possible to give a big descriptions here, but I can try to give some glimpse so that you will be getting a little more additional information. And let me open my presentation so that we can see some visuals also. Where is it visible?
Not yet, ma'am.
Not yet. Okay. How much time you can give to me?
No constraints, ma'am, please.
Okay. No, I can, accordingly, I can plan.
Your flight time would be, our constraint. Apart from that, actually, we are free to hear from you.
No problem. It didn't appear so far?
Ma'am, your screen is visible, ma'am.
Okay.
The team screening is visible, ma'am.
So whether the presentation is visible now?
Perfect.
Okay, fine. So I'm
Yes,
talking about geosynthetics. I'm talking about bioengineering products like coir and jute and the certain steel products. But the theme, basically what I want to highlight is how these type of products, which are, we can call it as relatively new, because definitely all these type of applications are not very new. The last 40 years, we are using the geosynthetics, the polymeric products. Coir and jute, those are more for us Indian origin, and it was being used by our ancestors themselves. And many of these steel products, whatever I am talking about here, it was in crude form. It was in practice in our Himalayan states. So nothing is very new. But nowadays, we are hearing a lot about these type of products. The single reason is that traditional construction materials like concrete, aggregates, those are facing an issue, especially in many parts of the country. We know the mining is banned. The stone or the aggregates are becoming quite costly. So naturally, everyone started thinking about alternate material. So that is a need of sustainability. But blindly going for some polymeric products or some other products may not be helping the sustainability. It has to be utilized in the right way. And it definitely will give someone business, someone profit. But what we need to see that whether the knowledge, the selection criteria, the monitoring part, the quality considerations, whether the awareness is really penetrating to the academic arena. That is very, very important. Without it's implanted in the mind of the future engineers, it can never ever become a accepted popular technology. So I take it as one of my mission that wherever it is possible, try to share this part of the knowledge and see that what is the frank feedbacks and responses which is coming from the new generation. So I would like to understand the feedbacks from all of you. May not be immediately you have to share with me, but you can very well write to me later. So the flow of my presentation is going some introduction, of course, then pavement optimization and drainage. I talk about the aggregate scarcity. Kilometers and kilometers of road is getting developed in India, getting repaired, and we are hearing even in the COVID time, one of the agenda of the government is to make more infrastructure projects to happen. So the road sector, the railway sector are going to be the main fields where the government wants to invest money. But at the same time, the natural resources we cannot use in plenty. So the pavement optimization, if some material or some technology is helping us, that is really a very appreciable move. Then ground improvement. Ground improvement, of course, this for the civil engineers, especially one who is working in the geotechnical field, it's very important because nowadays the construction is not happening in the best ground. So ground improvement techniques is not about going very deep excavation or using very heavy foundations like piling or raft foundation and all. We may have to utilize some techniques which can be done in a more simpler way, but maybe more effective. Then slop stabilization, as I mentioned, I work in a lot of disaster mitigation projects, and in that, many of the time, what a civil engineer can do is to stabilize and protect. Then hydraulics. Definitely, we do have very big coastal environment, and India is a land of rivers, especially holy rivers. But all these rivers and our coastal areas are subjected to a lot of erosion, a lot of other calamities. So something which can protect and stabilize these shores which are subjected to hydraulic forces. So these are the main touch points which I want to share with you, and what can be the mission forward. So coming to the roads and highways, I'm more talking about the flexible payments, even though these type of innovative products can be used in the rigid payments. And one of my earliest works in India that was started with some rigid payments, but let me start with the flexible payments. We know that the flexible payment is made with the different components, starting from the bituminous part, then base, sub-base, and subgrade. And in that base and sub-base, where the aggregate consumption is maximum. And if we can introduce one material which may be having a extra cost, but at the same time, the aggregate thickness can be reduced, then definitely it will be an advantage, provided the durability also has to be enhanced. So one of the geosynthetic product which is helping us here is Geo Grid. So now come the question. Okay, a geogrid can, if I am introducing in a pavement layer, if the durability is enhancing and the thickness can be reduced, then how I know that which type of geogrid has to be used? So there is somewhere a selection criteria is required. Okay, so where we will get the selection criteria? Okay, so when we are talking about the base and sub-base treatment, the selection criteria we will be getting from the specifications in the Orange Book. I don't know whether you are aware of Orange Book. Orange Book is the standard specifications which is written for Highway Ministry for every material, every construction material. So for for all geosynthetics, the clause 700 is completely devoted for geosynthetics. And in the session 700, we will be getting the specification of the geogrid, which can be used for base or sub-base reinforcement. Okay. And in the same chapter, you can get the specification of the drainage composite. Let me take a pointer. Okay, for the drainage function as well as for asphaltic reinforcement, when it is, if we want to reinforce the asphaltic layer, again for increasing the durability, then we can go for geosynthetic inclusion or we can go for glass fiber inclusion. So that also in the Orange Book. Then for ground improvement, we can go for basal reinforcement. If the geogrid is placed in the foundation, it will be called as basal reinforcement. This basal reinforcement can be used as a standalone product, or it can be combined with the PVD. If a consolidation also has to happen, we can combine it with the PVD, prefabricated vertical drains, or with the sand drains, or we can combine it with the stone column. What is stone column? We can make pits in the ground and fill it with the stones, and those stones will increase the bearing capacity. It will increase the drainage. And if we want to have a uniform distribution of forces, you can have a geogrid at the top of it. So which is a combination of geogrid reinforcement or basal reinforcement and stone column. We can use the geogrid with a piling foundation also, a pile foundation also. So what is the advantage when we are giving pile? Why a geogrid is required? So if we want to optimize the use of the pile and even the pile cap, then this geogrid can play a part. The geogrid can increase the spacing between the pile. It can reduce the pile cap thickness. It can reduce the reinforcement consumption. So overall, there can be a very good economy in certain cases. Okay. So the summary of this slide is the geogrids. It is a tension element. We will come to that more. Geogrid is a tension element. It can be used in base or sub-base reinforcement of the pavement, which can reduce the thickness and it can increase the durability. It can use in ground improvement, where we can combine it with the PVD, or it can combine with the stone column, or it can combine with the piles. It can be again used in asphaltic reinforcement, maybe with the glass fibers or as a standalone product. And this will increase again the durability of the asphaltic layer. It will reduce the tendency of the reflective cracking and other type of the cracks. So now the question is the pavement optimization, how these geosynthetics can be used. Okay. So before that, what are the other types of geosynthetics? Okay. So GeoGrids, we have seen that it is having a very popular applications, but it is one part of the family. Okay, there are brothers, sisters, and cousins. So we will see that which are the other materials which are useful for the civil engineering applications. So the first is geotextile. It is a cloth, and even here subfamilies are there, like woven geotextile is there, non-woven geotextile is there. So woven geotextile is something where like a geotextile, like a textile, warp and weft direction is there. Non-woven geotextile is usually classified as needle punched or thermally bonded, depending upon the manufacturing method. So the different filaments, the polymeric filaments, if they are bonded by thermal means, after randomly placed, it is called a thermally bonded non-woven geotextile. Okay, it will be randomly placed. It will not be placed in warp direction and weft direction. If the bond is by mechanical means, like it is pressed together, then it can be called as a needle punched non-woven geotextile. So non-woven geotextiles are basically they are using for hydraulic purposes, like separation. If a contaminated liquid or if a contaminated soil has to be separated from a good soil, we can go for non-woven geotextile. If you want to do a filtration, what you want to allow the water to go out and soil has to be stayed back, we can go for a non-woven geotextile. But woven geotextile, they can be used for filter and separator. But what will happen if water is passing through it continuously, then the voids or the pores, it will be somewhere the void size will increase, somewhere it will decrease. So if we are using the woven geotextile, there can be somewhere the clogging happens, and there can be somewhere the void will become bigger and the erosion can happen. So better to go for non-woven geotextile for hydraulic use and woven geotextile for reinforcement use. Okay. In fact, 10 to 15 years before, in India, the maximum popular product was woven geotextile. We were indigenously producing here. Nowadays, all type of geosynthetics are getting produced in India. But woven geotextile was having the popularity and indigenous production. But nowadays, the woven geotextile consumption has reduced because non-woven is replacing the woven geotextile for the hydraulic application. And for all reinforcement application, different types of geogrids have come in the picture. Now I am starting with the geogrid. I talked a lot about the geogrid by this time, but here comes my introductory part. The geogrid also is having different categories. What are they? The most popular type of geogrids, I will say bonded geogrids, woven geogrids, like woven geotextile, woven geogrids, which are having warp and weft direction. Then there is extruded geogrid. Extruded geogrid is what you are seeing here. The photo is of extruded geogrid. These are in fact the best for using in pavement application. Base or sub-base, if you have to go for a geogrid, my recommendation will be to go for extruded geogrid. Why extruded geogrid for pavement stabilization? Because there is a junction efficiency. You can see that the junction is having higher thickness and it is having higher strength and efficiency. So this junction efficiency will make a better interlocking with the aggregate particles, and that is giving a higher strength compared to a normal woven geogrid or a knitted geogrid. Then there is geocell. I know that geocell is quite popular, especially in South India. It can be used for the ground improvement as well as in erosion protection. So, but whether we can use the same geogrid in, geocell in ground improvement and erosion, I will say no, because in a erosion protection, we used to go for a cheaper variety, which has to have only a confinement purpose basically. Okay, you can have some tensile strength also, but when we are using as a ground improvement, as a basal reinforcement, it need to have additional properties. So it will be a special type of geocell. Geocell can be used as base stabilization and sub-base stabilization also, like geogrid. The only difference is in the geocell, the mechanism is more about confinement, whereas in geogrid, the mechanism is more about surface friction, interaction, and the membrane mechanism. Then there are other products like geomembrane, a lot of hydraulic application. Water source department, a lot of application can be with the geomembrane for like canal lining. For landfills, landfill stabilization, we can have geomembrane. Geomembrane is a impermeable membrane, whereas all the three products, what we talked now, geotextile, geogrid, geocell, all are permeable, whereas geomembrane is a complete impermeable membrane where you can use it as a lining or a capillary cutoff or similar use. Then comes Geonet. Okay, so when I joined in McAfee, I was not able to understand that what is the use of a Geonet. I was seeing some samples, but I came to know after few months itself, this is a very hot product. That time in India, it was not getting produced. It was coming from some other countries like Brazil, then something from UK. So these products were extremely expensive at that time, but still there were the consumers. And what does it do? This Geonet, if it can be sandwiched between two geotextile, it will become a drainage path plus filter. So instead of a aggregate filter, which may be many times requiring some 600 mm width, we can use a very thin drainage composite, which is only microns or maybe millimeter. So a big space saving is there. But definitely the 15 years before this product, as I mentioned, that it was coming from abroad only and it was an expensive product. So definitely the India, we always look in the cost effectiveness also. So it was not, I cannot tell it as a very popular product, but the situation has changed. Now it is a popular and hot product. The last 5 years, a lot of national highway, state highway, the railway, airport, all types of infrastructure projects, the drainage composite is being used. And now it is not only the space saving. As I mentioned that instead of a 60 centimeter aggregate filter or aggregate drain, we can go for some few millimeter thickness drainage composite. But again, the saving of aggregates, that is also a factor. Now, finally, the Geomat. The Geomat is a erosion control mat. This is actually the somewhere it is the rival of Coir, as Sir said in his presidential address. But in many places, the Coir and Geomat are used together, because Coir is a fantastic erosion control media and it is having very, very specific properties, whereas the Geomat, which is adding the polymeric speciality, non-biodegradable product, the property. So that can complement each other. Whereas the drapability, the ability to retain the moisture, that all, the Coir is far superior than this synthetic mat. But when it is coming to the durability, when we have to add certain tensile strength and stiffness, there is an advantage for the Geomat. So we talked about the base and sub-base application of the GeoGrid. as well as subgrade, asphaltic reinforcement and drainage. So we can start with again with the rods only. As I mentioned that when we are placing a geogrid, especially extruded geogrid with the junction efficiency higher, it will increase the interactive friction and interlocking of the aggregates, and there is a membrane effect. So when the traffic load is there and even the dead load of the pavement itself is acting on it, so the different strains will come in the pavement layers, the tensile and compressive in nature, and the geogrid, whichever is inserted there, that will bend like a membrane, and this membrane can give a extra mobilized shear resistance like a pre-stressed tendon, how it can contribute the additional strength. So with these three mechanisms, the resistance which will be offered against the traffic loads and its own self-weight will be much better than the non-reinforced pavement. And as I mentioned that the drainage composite, that is a drainage net sandwiched between two geotextile, that can replace a subbase when especially the drainage component that can be replaced. So when we are using these products together, we may be able to reduce the pavement thickness significantly. So I mentioned a few case studies here. These case studies, in all these case studies, if we are having time, we can go to there. But what I mean to say, the client has achieved some 20 to 30% of the total cost benefit, as well as the time benefit. Time benefit almost 40 to 45%. The productivity increase was there, and the overall time for construction has decreased. So now coming to the asphaltic reinforcement, I mentioned that we can use polymeric products as well as the glass grid also. And sometimes it will be a combination of a composite which is combining the paving fabric and glass grids that can be used. And the advantage is the prevention of the reflective cracking. If the cracks which are propagating from the bottom layers of the pavement, which will be coming to the surface, and during the monsoon time, the water will go inside and it will become wider cracks, and that will get prevented by the inclusion of a paving fabric or even a composite where glass fiber elements and the polymeric elements are combined. So again, how the selection will happen? The selection depends on the traffic load, the type of durability we want to enhance, and the of course the fund availability also. For example, so the glass fiber inclusion will be the one of the cheapest, whereas there is a steel mesh called rod mesh which can be incorporated as a asphaltic reinforcement. So if we want to increase the durability to say 20%, we'll go with the glass fiber only. But if we want to almost double the durability, we may go for the rod mesh, but the cost will be more. So if the glass fiber inclusion can be done by say a 200 per square meter, if we go for the rod mesh, it may be 600 to 700, but the durability will be almost doubled. So the design factors is, apart from the strength, the stiffness of these elements, as well as the pavement components, the CBR value, the modulus value, apart from that, definitely the durability is one of the design data, and definitely the fund availability also will be governing as a one of the input which need to be considered. Now coming to the drainage. Okay, So the drainage, we already spoken about the drainage composite, which can save the space, which can save the aggregate, and it can be used in horizontal direction as well as the vertical direction. So which are the horizontal utilization of the drainage composite in railway track or in roads? So when we are going for a road, definitely we have to give the longitudinal drains, as well as we may have to provide the transverse drainage. We have to give culverts. We have to give even in the pavement, we have to give the subbase layer, we have to give. So here, when we replace it with a drainage composite, what are the main considerations? The main considerations are the ability to carry water. Okay, the discharge carrying capacity is the most important. So here comes the comparison. So when we are designing a gravel drainage path, we don't have to consider that much about the durability. But when we are thinking about a drainage composite, which will be acting as a drainage path, there the durability is very, very important. And another aspect which normally the designers will forget, when the pressure is acting on this type of a drainage composite, there will be some distortion can happen beyond a limit. So that means that when we are using the drainage composite, then the force which is coming on it need to be understood. Especially this is important when we are using the drainage composite behind a retaining wall or in a vertical direction, because when we go in deeper layers, the pressure will increase. So the behavior of the drainage composite with respect to the different depth has to be considered. But this is not a complicated issue for someone who is familiar with these products, because usually all the manufacturers used to keep these data, the drainage composites, its discharge capacity, as well as its ability to retain its shape under different pressures. That data will be given in the manufacturer's technical data sheet. Okay, so if an engineer is using, he is the user and he is having every authority to check with the manufacturer what are these data, and please give me your manufacturing or your technical data sheet, and that sheet will be carrying all these information. Okay, now let us go to the another application of the geosynthetics. It is ground improvement. So as I mentioned that the geosynthetics is having a very good ability to reinforce the ground, acting as a basal reinforcement. It can do wonders. In many projects, one of the project which was a real challenge to address the liquefaction potential, that is Geomat Expressway. Okay, I was involved in that project and we were really worrying how to account the liquefaction potential, and at the same time the project has to be completed within a specific time, and there is a budget limit also. And the basal reinforcement, a bonded geogrid, we have used in Geomat Expressway, and that has eliminated the use of very deep ground improvement techniques. Okay, of course in some places they have to use dynamic compaction with the basal reinforcement, but in many places the deep ground improvement requirement was eliminated by the use of the basal reinforcement. So it is acting like a raft which is allowing the redistribution. It will be a stiff layer. Usually the basal reinforcement will be a geogrid which is having high stiffness and high strength, and this material will act like a raft redistributing the pressures. There will not be any chance of localized strains or stress, and it will up to an extent. up to a good extent, it will eliminate differential settlement. It will not nullify the settlement. Okay. If anyone is telling we can use GeoGrid and we can eliminate the settlement, it is totally wrong. It will not nullify the settlement, but it can minimize the differential settlement. And in a poor soil, if a clay soil or a very fine silty soil, if we can control the differential settlement, that is a great economic advantage is there. Okay, and it is better to use single layer of GeoGrid rather than number of layers. Okay, so again, it is a point of optimization. There is no point in digging a lot and placing number of GeoGrids one above the other. Okay, so if somebody is telling like that, they are fooling you. It's better to go for single GeoGrid layer which is having high strength and ensure that it is having enough stiffness. So that is a good basal reinforcement proposition. But suppose if we are not having a high strength GeoGrid, okay, you are in touch with a manufacturer and he doesn't have, he is giving you a special discount. He's so happy to give to you and support you, but he doesn't have a high strength GeoGrid. When I mean high strength, it is something more than 200 kilonewton per meter and all. Still you can use it. Still you can use it in layers, but by taking little extra measures. Then prefabricated vertical drains, as I mentioned that we can combine the prefabricated vertical drains and GeoGrid as basal reinforcement. What is the use of prefabricated vertical drains? We all know that they are the drains which will be accelerating the consolidation process, so that if we construct a structure or an embankment or any type of civil engineering infrastructure above a poor soil, which is having the tendency to consolidate, the prefabricated vertical drains will reduce the drainage path and accelerate the process of consolidation, so that the post-construction settlements or the post-construction strains will be minimum. Okay, but in those type of cases, there can be a localized stresses and strains can come, and that can cause problems. And sometimes when we are doing the preloading, which is required for the acceleration of the consolidation process, there itself some collapse can happen. So if we are providing a geosynthetic, either a woven geogrid or even a woven geotextile, then we can eliminate those type of incipient failures. The same way as I explained, like we can combine the basal reinforcement, the GeoGrid, we can combine the basal reinforcement with the piles as well as with the stone columns. Everywhere the use is same. It will act as a stiff layer which is helping to redistribute the pressure, the stresses and the strains, and it will eliminate the tendency of any differential settlement. Suppose if it is an embankment and the side slopes are steep, and if there is a chance of rotational slip, again a GeoGrid which is acting as a basal reinforcement, that will improve the resistance against the rotational slip. So when the GeoGrid which is acting as a basal reinforcement, while it is improving against a differential settlement, it will improve to a certain extent the resistance against lateral sliding, and at the same time it will improve the resistance against rotational slip, so that we can go for more steeper side slopes. And what is the advantage of going with the steeper side slopes? We can minimize the space consumption, isn't it? When a national highway or state highway is constructing, the requirement of land acquisition that will become a major concern. And when we are going for steep side slopes, we can reduce the space consumption requirement. So basal reinforcement, there is a design code which is published by Indian Road Congress, which is IRC 113. It is talking step by step the different principles. It will be definitely guiding the civil engineers, especially the foundation engineers and the structural engineers and highway engineers. If we go for constructing a highway embankment over a soft soil, especially if it is in a coastal city like say Chennai or Visakhapatnam or Kochi or Calcutta. So many times we may have to construct big embankments over very soft soil, which is extending up to 20 meter or 40 meter. So that time we can really think of using a basal reinforcement uh, for controlling the differential settlement, improving the resistance against rotational stability, sliding stability of the embankment soil, and if there is a tendency of lateral extrusion and plastic squeezing, that will get prevented. But many times when we are using a basal reinforcement, we may not be getting enough anchorage length. Okay, there should be a certain length beyond the side slope so that it can get anchored. So in that case, we may have to use two anchor blocks at the end, and this geogrid can get wrapped around on these anchor blocks. So prefabricated vertical drains, I'm skipping this because the geosynthetic component is minimal there. But let us see this diagram. It's a live project which is at present happening in Kerala. So we can see the road, and there is a rainfall soil structure. This is again another application. A geogrid can be used as layers, and it can be used as a strengthening material for constructing a retaining wall. So that is rainfall soil wall. I think it is a popular type of retaining wall at present in India, and this is supported by a basal reinforcement, and this basal reinforcement is over a foundation strata where prefabricated vertical drains are being used for the consolidation. Okay, which we were talking, and we can see that a number of heterogeneous layers are there. So it is clay, then clay sand, then gravelly sand. It goes like that. So the drains are extending from the top layer up to the strata where sandy gravel is there. Okay, because all these layers, some clay uh, uh, percentage is there, which is really having very low permeability, and with the addition of the band drains, it is really encouraging the drainage momentum, and within a particular time 95% consolidation is getting achieved. And when consolidation is getting accelerated, the shear strength will be improving. So if cohesion is 10 kPa, it is going to increase to say 25 or 30 to 35, and that will make the bearing capacity to get increased. So the stone columns, in that my area is not just a stone column, it is in fact geosynthetic encased stone column. Suppose if I am making a stone column, what is stone column? I am making pits in my soft soil, which is soft clay, for example, soft clay. And there I am putting my stones. Will my stone column stand there? No, the stone column may get bulged out. So if I am inserting a geosynthetic encasement, it will be called as a geosynthetic encased stone column. And in that case, what my encasement will do? My encasement will act as a stiffening layer, which is giving a extra strength, and I can use it as a filter and separator also. It will not permit the clay to interfere with my good stones and contaminate it. So it will act as a filter and separator also. So geosynthetic encasement, it will increase the strength, it will increase the stiffness, and it can act as a filter and separator. So for the geosynthetic encased stone column, what we are facing at present in India, the guidelines, the complete design guidelines are not available. So far we are using the German guidelines, but the references about the geosynthetic encased stone column, that is, it is in the IRC 75, the latest edition, as well as it is there in HRV 13 and 14, which is published almost 20 years before. So the code is permitting us to go for the geosynthetic encased stone column, but it has not become enough popular because the design and analysis methods are still, we have to go for the German codes. Now coming to the slop stability, it's again a place where a lot of this type of flexible structures can be used. So one of the simplest type of material which can be used in slop stability, those are steel gabions, which are having the flexibility which is permeable, because usually these are made with the steel meshes, and the steel meshes will be having a lot of openings, and it will be filled with the stones which will act as building blocks. And this is a gabion wall, and this gabion wall is usually having a base width 0.5 to 0.6 h. So if it is a 4-meter high gabion wall, the base width has to be 2 to 2.4 meter. And the advantage of this type of structures is it is flexible. So there will not be any cracks or any type of eccentricity which is getting developed in a gabion wall. So we can reduce the foundation requirements to a minimum. Second, the advantage of this type of structures, the vegetation can easily take its roots through it. So during the monsoon, many of us seen a lot of retaining wall failure, but these type of gabion structures are permeable. It will allow the water to go through it, so this sudden increase of pore water pressure will not happen there. And as I mentioned that even big tree roots can take its way through the gabion walls, and tree roots only will stabilize it. It will not crack it. So then another application of this flexible structures, that is reinforced soil structures, I mentioned about it. So whenever we want to construct a steep slope, if it is a slope which is very gentle, say less than 45 degrees, then we can go for just a slop stabilization and erosion control. But when we have to construct a steep slope, we may have to reinforce it. And reinforced soil is no longer a new technology. It is very popular in India. In fact, it may be interesting for all of you, and we can be proud in the whole world, among the different countries, maximum fascia area of reinforced soil construction is at present happening in India. Even my colleagues in abroad, when I am talking, I'm talking in lakhs and lakhs of square meter, when they are talking in hundreds of square meter. So that is the way the reinforced soil became popular in India. One of the main reason is it's all in, when it is coming to India, always it is economic advantage. The one of the main reason is the big saving potential. Okay. So usually the reinforced soil will minimum give 25 to 35% cost advantage if it is a comparable type of soil, a reasonably good soil. And the advantage, cost advantage usually used to increase if it is a more poor soil. If the soils, the condition is going down, its economical advantage will be increasing. So here the main reinforcement will be a geogrid, and the fascia system will be a vegetated fascia, which is a steel element which is acted as a or created as a woven steel mesh, which is backed with a coir geotextile to facilitate the vegetation. Okay, So geogrid is going inside and it is strengthening, and a fascia is there which is protecting the slope with the erosion. There should be a connection. It is a big topic, so I am not going to there. And you see that the bottom part of this reinforced soil structure, it is in fact again a main reinforcement is going inside the soil, but the fascia is made with the gabions. So gabion with an integrated tail, and there is an overlapping of this integrated tail and geogrid almost 3 meters. So this is a national highway project in Kiratpur, NH21. You can see the initial the embankment, road embankment, and then the construction of the reinforced soil structure with a vegetated fascia. We are not seeing any structure, we are seeing only vegetation, but it is a reinforced soil structure. Here it can be a 35-meter RCC wall, and think about a vegetated structure, okay? Vegetated structure which is more environmental friendly, and most of the material which is being used, okay, geogrid has produced in factory, but the rest of the material is whatever the natural soil which is available in that locality, and the fascia is the vegetation. Yes, coir has come from Kerala, but the vegetation is the natural species which is common to that area, okay? So I talked already about reinforced soil structure. The main reinforcement can go like this. Then the fascia, if it is a gabion, gabion will be having an integrated tail, or it can be a vegetated fascia where a woven mesh element with a coir geotextile together will be facilitating the vegetation, which can create a very beautiful aesthetic appearance like this. Or if you like stone fascia, you can go with a gabion fascia, provided good stones are available. We can use any stones which are normally used for stone masonry. Or if you want a concrete fascia, okay, in city limits and all, we may not want sometimes gabion fascia and all, we may want a concrete finish. So in that case, we can go with the concrete panel or segmental block, which are all these concrete panel, gabion, vegetated fascia, all these are erosion control measures, whereas the main element is, as I told, that our hero is our geogrid, which is going inside, which is having a high strength and stiffness value. Okay, now I am touching one more area, that is rockfall mitigation measures. I mentioned about this earlier. I want to touch this also because nowadays, apart from all McAfee's work, I find a lot of happiness in engaged with disaster mitigation work, and especially where my expertise is having some meaning, like slop stability, and in that a very peculiar type of slop stability issue, which is in Himalayan terrain, our Konkan terrain, and in Nilgiris, that is actually rockfall. Rockfall is a type of landslide where rock will detach and will fall under gravity. Okay, more vertical fall is happening. So this is an extract from IRC HRB 23. I was one of the main author of that Highway Research Board publication. It has not become a guideline so far. It is still in a state of art. So there are 4 types of rockfall mitigation measures are there. One is rockfall warning measure, then rockfall protection measure, then rockfall retention measure, and rockfall prevention measure. Okay. So warning measure is digitally we can give a warning for the user or a driver who is driving a vehicle that a rockfall can happen in a particular place, and that will prevent the disaster. So it is not preventing anything, it is just a warning. Second is a protection measure. Like in a slope, if you are providing a beam or benching, the rock will not directly fall on a vehicle or a passenger. It will by the time if it is falling at the beams, its energy will be lost, and finally it will be a non-risk activity. Then drapery system, different types of meshes and nets will hold the rocks together. Okay, so whatever the forces which is coming from inside, whether it is radiant or hoop stress or whatever it is, the rocks will stay together and it will act opposite to that. Then there are rockfall barriers and embankments. Even we can make steel barriers or steel embankments, sorry, not steel embankments, even earthen embankments, which is reinforced with steel, which can act better than concrete barriers or concrete embankments, which will be more having sustainability point of view, more value, and technically more effective. Then rockfall ditches and trenches, rockfall attenuators, debris flow barriers. Debris flow barriers in my state, even Kerala, as well as Uttarakhand, a lot of debris flow happens. These debris flow are more dangerous than rockfall because it is with a lot of fragments. Water also will be moving with very high energy, and this will cause very big disasters. So if we can create some barriers in the path of this debris flow, then those are called debris flow barriers. Then rock sheds and tunnels, if you are going to again in Uttarakhand, in Vaishnava Devi temple, you can see rock sheds there, which are really preventing the rockfall. Then again, it is not any prevention of rockfall, it is actually protecting the infrastructure. Then rockfall retention measures. So different types of short nails and meshes, those are, it is retaining the rock in its place. Those are retention measures. Then shotcreting is a type of retention measures. Then prevention measures. What are prevention measures? Drainage is a prevention measure because prevention measure means you are preventing the rock detachment. So one of the main reason for rock detachment may be water flow. So if you are removing the water, then with the possible drainage, then that can be a prevention measure. Deep nails, if you are completely nailing the rocks to its parent rock, that can be a prevention measures. Okay. So when a barrier is being used, as I told that steel barriers, okay, steel barriers, they are replacement of the earlier rigid concrete barrier. One of the advantages when we are using a steel barrier, you can go with a minimal foundation, okay, and these steel barriers are certified by specific crash test. What is a crash test? When a particular company is producing a steel barrier, I cannot just produce a barrier and tell that, oh, this barrier will work, it will absorb this much energy, it can place in a particular place of Himalayas, it will prevent all rockfall. No, I have to get the certification, then only that will be useful, or that will be I will be considered as an authorized manufacturer of the steel barrier. And for this certification, there are certain codes and guidelines are there. That is already, it is covered in this Indian Road Congress, HRB. And the Bureau of Indian Standard is formulating the guideline for the standard terminologies as well as the test methods for these barriers. And the barrier component, the most important part is what you are seeing, the mesh which is forming the barrier. So that is already an Indian standard is there. Okay, so that is the good news. ISO, IS 17745 and 46 are talking about all the different meshes which can be used as the steel barriers. Okay, it was an ISO document, and that is adopted by Indian standard the last year. And this ISO IS documents is giving the material, the terminologies, the testing method, and how it will work. And if any time repair has to happen, how it is to be done, so that n number of times the same barrier can be used. And one more before I am concluding. So this is about the different types of drapery systems. I talked about different type of steel meshes that can be used as the drapery system, which is holding the rocks. So in the drapery system also, a civil engineer can play a part, because a lot of applied mechanics principles we have to use here. The drapery system can be simply pinned at top, or it can be pinned at top and bottom. Sometimes it has to be reinforced. Sometimes it has to be, none of this will work. A panels has to be used which is having high energy absorption capacity. So how we will decide what type of mesh has to be used in particular places? For that, deep understanding of the geological formation of the rocks, where the joints are there, what type of fragmentation can happen, that has to be there. So a geologist who is familiar with the area will be a very good companion of the civil engineer here. But definitely with our repeated experience, that expertise we can also gather, but it will be better that we are really taking the advice of a geologist. And sometimes a multi-specialist team itself is required, okay, with a civil engineer. A hydrologist also may be required, but the main activity is, again, it is resting on the civil engineer only, because the entire analysis need to be done, the static analysis and the dynamic analysis. And again, we may ask that, okay, we are not studying all this in the 4-year BTech curriculum, but whatever we are studying in our mechanics classes, that is enough. There are the softwares which are available, which is helping us to simplify the complicated analysis. Once we know the basic principles, whatever we are studying in the beta curriculum, that is well enough. But this software will tell us that where the maximization of the stresses will happen, whether the static forces are critical or the dynamic forces are critical, okay. And even for these barriers, where the barrier is to be placed, that depends on the projectile motion, okay. Again, there are the softwares which are really helping us to understand that the different type of simulation, which is the worst critical type of combination, and where we have to place the barrier to prevent a rockfall. Okay, interesting, isn't it? So the last slide which I am presenting, that is actually rockfall embankment, because I was talking about the sustainability. That is why I want to talk about this. In many places, a steel barrier will be a big welcome, because it is requiring minimum space only. Okay, minimum space only. But in certain cases, steel barriers can become an expensive option, and in that case, we can go for an embankment which is made with the soil only. So where we are having some space, and then we can create an embankment, a trapezoidal embankment. There we can go for the earthen embankment, okay. And it can be reinforced. It can be reinforced if you want a steep slopes, okay. And now currently a project which is happening in the Jammu and Kashmir, there rockfall embankments are being used. It is not rockfall barriers. Another rockfall embankment which we have done in for Saptashringi temple. So in front of the temple, barriers and embankments are to be constructed. So somewhere where space is got, we went for an embankment, and somewhere barriers were conveniently placed, we went for the barriers. So I'm stopping here because I really want to hear your response. I do have more slides, but I prefer to hear from you before I am continuing with the rest of the slides. As we have already taken almost 1 hour. So I would like to hear any queries or any feedbacks. Then I can, while I am answering, I can use my remaining slides also.
I request students to drop. I think, ma'am, actually the voice privilege is not given to all the students. I request a few of the students to drop their question in the chat box. Otherwise, actually, you can raise your hand so that actually we can permit you for, for the discussion.
Manish Reddy. Yes, Manish, welcome.
Admin, please ensure that actually we are unmuting the person who are raising their hands for asking questions. Yes. Yeah, ma'am. Meanwhile, actually, I just wanted to have a small query, ma'am.
Yes.
Hello, ma'am. Yeah.
Yes.
Ma'am, actually, very recently there was a work which was associated to the embankment erosion protection for one of the coastal area project, which is near to Karakil. So they were always thinking about some cost-effective methods by which actually they can go for the erosion protection. So while you were suggesting one of the, I think, Geomat, I suppose, Geomat was being advised, or if I'm not wrong.
Okay, for coastal erosion protection.
Coastal, ma'am, actually, it is basically an embankment for railway.
Okay.
So, so they were anticipating, water table to reach somewhere around, 2 meters or 2.5 meters in the embankment level itself.
Right.
So they were asking for some erosion methods. So what is that actually we can suggest to them? I mean, so that actually it is cost effective too.
Right. So in that, if we are going for a embankment which is subjected to some water forces, whether it is from coastal or from river, okay. The first and foremost is to find out basically the geometry. Okay. So if it is a slope, whether it is a gentle slope, whether it is a steep slope. Then second is what are the real forces which is coming, whether it is causing a severe erosion or a mild erosion.
So compared to, just to add on, there was plenty of rain cuts when I visited the site. Actually, there was plenty of rain cuts also, which was visible on the surface level.
Right. Yes. So the third is the type of strata. Okay. So what is the type of strata there? Is it sand or
it is mostly silty.
It is silty. So its erosion tendency is quite high. Okay. So silty will be having, it is a maximum erodible material. Okay. Now the second is the slope. The slope is whether it is, what is the gentleness of the slope, if whether it is less than 45 or 45 to 60 or 60 to 80 or what is it?
No, ma'am, everything was maintained lesser than 40 degrees.
So that means that it is gentle slope. It is gentle slope. But when it is silty, the first is we have to ensure that whether it is geotechnically stable. So if it is silt, then the friction angle may be, there will not be any cohesion. Friction angle may be, means say less than 28 degree. So still between 28 and 40, there can be a geotechnical instability can happen. So first to ensure that geotechnically it is stable, the slope. So there should be a stability analysis need to be conducted. Now second, coming to, if we find that the geotechnically it is not stable, we have to provide something, maybe a little retaining wall, so that the upper part, the surcharge slope can be made gentle and all. Once we ensure that it is geotechnically stable, then comes the erosion. So the erosion, again, many times it will be a combination of different erosion. It may be the water flow, it can be some wind erosion or whatever it is. But here I assume that it is basically because of the wave erosion, right?
Yes.
Okay. So if it is just the river flow, then the erosion, the all the equations, tables, everything is quite simple. Okay, you can very straightforward. You can find out the velocity and tractive shear force, and there is whatever be the erosion protection method, whether it is a geomat, whether it is a riprap. Riprap means stones. So there are different types of tables are there based on the empirical relations and all. But in a coastal where wave attacks are there are more parameters to be considered, like apart from the velocity as well as the tractive force, we have to consider the cyclic nature of the forces and the wave height and the tidal variations. Okay, but all these dynamic forces are to be considered, but the most important part is many times just a geomat or any type. Geomat can be biodegradable material, geomat can be polymeric material, but alone it may not be sufficient.
Got it, ma'am. Actually, I understood the concept, because main thing is whether they are stable geotechnically or not. That itself is a big question.
That itself, and then the dynamism has to be completely understood. And once means, see, we have to start eliminating the forces which need not have to be worried. Okay, and finally we have to address what is important, and then we can find out. Okay, so geomat is a very good type of erosion protection. Once it is getting a stable surface where it can hug it. Okay, one of the fundamental principle is a geomat, whether it is a coir mat or a polymeric mat, whatever it is, it has to hug completely the surface, and then only it can act as a media to make the vegetation, because it is actually a media. Okay, the geomat will hold the soil, but finally a vegetation has to happen. Okay, and in a coastal environment, it may not be, the vegetation may not be easily surviving also. So with the geomat, we may have to have some additional measures.
Or else we may have to identify the native species of grass or whatever, which will be able to hang to the condition. Yeah, got it.
There are species which will work even in a coastal environment also. We may have to take a little help from a local expert who can suggest the plants and all.
Okay.
We may require only hours, but we have to utilize their time. Okay.
Got it. Thanks a lot.
Any other? Manish Reddy was raising the hand.
Excuse me, ma'am.
Yes.
There is a question that's been posted in the chat box.
Please. Can I see that, or someone can read it?
Yeah. One of the questions is actually, since they are polymer-based materials, which are being used as reinforcement, so do they have any impact on the soil in the longer run?
No. See, the material has to be inert. Okay, it should not affect the soil properties. It should be inert. That is one of the criteria for the selection of the raw materials which are being used for this type of geogrids, which are used in soil reinforcement.
Yeah, any more questions? Okay. Any more questions actually which you want to raise?
Thank you, madam. Your lecture was very inspiring. This is Dr. Karthikeyan, Associate Professor, ma'am, from Civil Engineering. I have a small live problem, a query. Actually, there was a site which was built across a river stream. And what happened is, while constructing, the water table was too low. When there was heavy rain in the recent months, some 4-5 months ago, what has happened is the water table has suddenly raised, and what happened is the floor level and everything got smashed, ma'am, because of the extreme pore water pressure. Okay. And the basement level, everything was completely damaged in that site. Oh. So already people are occupying, and sudden mishap has happened like this. In that aspect, how can we arrest this pore water seepage? This is an unusual problem, but at the instant, how to arrest this, ma'am?
Okay, sir. After this, I will call it as a disaster. Okay, because it was unexpected. It was unexpected and not predicted. Which was really very unfortunate. But any investigation happened after that to understand that from where the source of this unpredicted water has come?
Actually, it is a river stream, ma'am. They just constructed the plots very closer to the river
It is
stream.
river stream only. Okay.
Yeah, it's a
Right.
river stream, actually speaking.
Okay.
And
Okay.
then,
But any dam was opened or anything?
No. Actually, what has happened is that is a lower level area. There was a severe downpour, say some 5 months ago. And because of that, the water level abruptly, the groundwater level has raised.
Okay, just with the downpour. Okay, right.
Just with the downpour, it got raised, and excessively there was some pore water pressure, and the basement level, everything was collapsed at one stage, and the building is about to fail.
Okay.
Because of.
Okay. But, okay, and what was the foundation of the building?
It's a open column type foundation only.
Foundation type of the building, sir?
It's an isolated footing.
Okay.
It's a small
and it was
residential.
not at all designed for any type of this type of water attack or anything.
It is just
Okay.
like an
Sir,
residential.
I will really suggest a complete forensic. Right. And can you share with me any photographs or what is the surrounding area? How is it? And something.
Right now, I don't have
Because,
it here.
Here we really have to first. Okay. Please share with me, sir. I can have a separate discussion.
I'll just mail you. Okay.
Quite. Yeah.
Yes,
please.
Okay.
See I will say that without the complete understanding of that, the soil, the water, the building loads, because everything together will be acting, right? The soil water structure interaction. So without that, we will not be able to really talk anything. And the building, is it multi-storied?
Oh, it's just G+1, ma'am. It's a small residential building. Only thing is, it was rigidly jointed, and once that pore water pressure has come, it got seriously uplifted.
Okay.
And the basement, everything. Right. I will share you the video also, ma'am. Right now, I don't have it here in my desktop. Once after that, I will take your mail ID from Jeevan, and then I'll just show you the things, ma'am.
Right. So I don't know what is the condition now, but if we are having some feeling that somewhere means NC already constructed and then an uplift can happen, okay, which was not predicted and all. If the space is permitted immediately to immediate vicinity of that, then apply some gravity weight. That is the most simple thing. Okay, like counterbalance. Provide some counterbalance. Provide some gravity weight so that that uplift will be counterbalanced. That is the most simple. Second is whether we can insert some drains. Whether some horizontal drains or something can be really or inclined or something can be means and say inserted that so that the water will not accumulated anywhere. But in this case, sir, I would like to see the entire surroundings and the details of that so that I can suggest something.
Yeah, thank you very much, ma'am. I'll do share that.
Right. Okay. Thank you, sir. Any questions from any female students? No females. I don't have a gender bias, but I with my limited interaction with the NITT Trichy, I feel that a lot of very smart female students are there.
They are, of course, they are, ma'am. They are. The only thing is that actually they are slightly, maybe shy to ask it. Yeah, Shimrit,
Right.
any questions from your side? Shimrit? Okay, okay. Okay. Yeah, Maitri, shall we proceed? Ma'am, how about your timings? Actually, are we running short?
I prefer to conclude if you all permit.
Sure. I got it, ma'am. Got it.
Yes.
Your time is
Yeah, but I can share my presentation because it is having a lot of case studies, a lot of other extra details, and all are welcome to definitely interact with me.
Definitely, ma'am.
Let it be a more starting of a journey together. So
Sure,
I will share the presentation with Dr. Jeevan so that the participants can get it.
Sure, ma'am. I'll definitely do it.
Yes, ma'am.
Yeah.
Thank you, ma'am, for enlightening us with the intriguing presentation. The sustainable solutions you have presented for pavement optimization, such as ground and drainage improvement, asphalt reinforcement, sub-base treatment, and rockfall protection measures, truly helped us probe into the depths of geosynthetics and road pavement. Finally, we would like to welcome another member of the working force, the General Secretary of CEA 2022, Mr. Prasanna, to deliver the vote of thanks.
Yeah, thanks Maitri and Abhishek. It's my privilege to deliver the vote of thanks on this occasion. A very good afternoon to one and all present here. Thank you all for attending this inauguration session of CEA 2022 and spending your precious time with us. Individually, first I would like to thank our beloved chief guest, Mrs. Minimal Kurulla, for her esteemed presence by taking time out of a busy schedule and attending our inauguration. I'm sure your moving speech and insights shared through the presentation has given the young minds here a vision and an inspiration to excel in their careers. I'd like to express my deep gratitude to our beloved HOD, our very own Professor Dr. G. Swaminathan, for serving as a constant pillar of support. He is the light that is guiding us in times of darkness and by always being there and motivating us. I'd like to express my deep gratitude for Professor Jeevan Joseph, the faculty advisor of CEA, for the unrelenting support he has given us. He made sure we never went off the track and put in all the necessary inputs and guidance we needed to achieve this feat. Further, I would like to thank our Professor Dr. Moses Santakumar for gracing this ceremony and delivering the presidential address. Also, I'd like to thank the chairman of this edition of CEA, Mercedes, the overall coordinator, Elilarasan, the treasurer, Siddhartha, vice chairperson, Shruti, assistant treasurer, Haswant, and other co-members for shouldering the responsibility of leading this year's CEA with diligence and commitment. And finally, I'd like to thank you, the audience, our beloved faculties, friends, for gracing this occasion with your presence. A special mention to my batchmates and juniors who have been our comrades in arms and have been putting their best efforts to ensure the smooth flow of CEA. With that being said, we promise to work hard for the grand success of this year's CEA and hope to have an exciting edition of Moments, our department's national level technical symposium, which is all set to happen in a very few weeks. Once again, thank you all and have a great weekend ahead. Thank you.
Thank you, Prasanna. And with that, we come to the end of the inaugural ceremony of the Civil Engineering Association. We request all of you to meet